Welcome everyone to this new session of the Policymakers training. This training is offered by the Quantum Flagship Coordination and Support Action, QCATS. Its aim is supporting policymakers in Europe in making informed decisions in the performance of the duties. So I'm Diana Tartaglia, and today I'll be your host and moderator for this session. I will start sharing a few slides. The team behind this Policymakers training is composed by Dr. Oksana Mishina, whom you might already know from previous sessions, and Professor Costanza Toninelli, scientific head of this working group. This Policymakers training, as I said, was born with the scope to support policymakers into the performance of the duty and to create a shared language that would facilitate the cooperation among colleagues all over the world, but also to create some connections with quantum experts in research and industry. So in these past sessions, we heard about the quantum ecosystem in Europe and international initiatives and cooperation worldwide. Quite a few sessions were dedicated to use cases. We covered all the pillars of quantum technologies, from metrologies to quantum communication to sensing and quantum computing. Well, today's session can be considered some kind of the second episode of the last one, the previous one. In fact, last time we talked about the state of the art in research, or that is the future cases of the industry of tomorrow. Professor Cataliotti from CNR-INO talked about the Europe Quantum Communication Network, EuroQCI, and the efforts towards a quantum internet, while Salvatore Sina from CEA made an overview of the strategic research and industry agenda and its importance for the development of technologies, of quantum technologies in Europe. Just a few words on you, participants who are connected with us today. So we have 129 registered participants coming from 34 countries, not only from Europe, but we have some of you who are connecting from outside of the European Union. Many of you, the majority of you, they consider themselves experts in quantum technology, so they keep themselves updated. But just very little of you don't know much or know nothing about it. We hope this will change after today's session. Finally, the majority of you are involved in research, and some of you in academia, and many is also in the government part. So today, as I said, we will continue the topic of last time, so the state of the art of quantum technologies, and with the contributions of Professor Yasser Omar, professor at the IST and president of the Portuguese Quantum Institute, and with Dr. Venkatesh Kannan, associate director at ICHEC. They will give us an insight on the future directions of quantum technologies and share the latest news from the European pilot EuroHPC HPC high-performance computer and quantum simulator hybrid. Just a few words before leaving the floor to our speakers. I want to remind you that today is not our last meeting. In fact, we will only take a short break for the summer, but there is already another session planned in September that will focus on more ethical aspects of the development of quantum technologies and the efforts needed for the creation of an inclusive industry supporting human rights for all the typically underrepresented categories. Moreover, we will like to share with all the participants a little evaluation survey to evaluate these first rounds of sessions that we just had. So now let me introduce our first speaker. So Professor Yasser Omar is currently professor at the IST University of Lisbon, where he leads the Physics of Information and Quantum Technologies group. He is corresponding member of the Portuguese Academy of Sciences. His research interests are focused on quantum computation, quantum networks, and the energetics of quantum technologies. And in 2019, he founded the Technologies Laboratory at the Quantum Technologies Laboratory at IST, where free space quantum communications were implemented for the first time in Portugal. In 2022, he co-founded the European Quantum Software Institute, and he has been involved in the creation and coordination of the Quantum Flagship. He's also president of PQI, the Portuguese Quantum Institute, and since 2022, he launched the World Quantum Day together with other colleagues in other more than 65 countries. So the 14th of April, thanks to him, is now a global outreach initiatives day, and he is involved in promoting the 2025 as a year dedicated to quantum science and technologies. I will stop sharing my screen, and Yasser, the floor is yours.
Hello, Diana. Hello, everybody. Thank you very much for the kind invitation and the kind introduction. So let me, it's a great pleasure to be here. Let me try and share my slides. Can you see my slides?
Yes, we see
okay.
that.
Thank you very much. So the challenge was to discuss some new trends, some new directions for quantum technologies. So just to be clear, what we mean by quantum technologies are quantum information technologies. So I think it should be known to the audience, but let me just frame the discussion that when we talk about quantum technologies, we're talking about quantum computation and simulation. On the one hand, another direction are quantum communications, and then quantum sensing and metrology. This is a very short talk of 10 minutes. So today I will be focusing on quantum computation, and there will be, I guess, future opportunities where we can discuss here or elsewhere new trends in these other pillars of quantum technology. So let me focus on quantum computation and a few messages. So first, a new idea that is emerging, and of course this is not completely new. These things have been going on already, and there are people around Europe and around the world pushing for these efforts, but they are still not so known. So I want to emphasize them here, is the idea of quantum computation, and in particular quantum algorithms for good, how to benefit humanity, and in particular trying to address these sustainable development goals that the United Nations have defined. And so in general, in quantum computation, good use cases are precious. There have been many scientific use cases and industrial use cases. And I think this is sort of a new category to some extent that is very welcome. And I think it should be more advertised and more known so that more people can join this effort. For example, until even recently, I was listening from the United Nations division called Habitat, where they also address the access to clean water and sanitation, how they are investigating the potential of quantum computation to help them address the very important problems they face around the world. However, I also want to send a general message that the quantum computational advantage, speed-ups compared to classical computers, are hard to find, and they are not always very spectacular. And so we should moderate our expectations. Having said that, I think this just justifies further effort, further investment in trying to attain these applications for quantum software. So this is one direction that is emerging that I find very interesting. The other, but also I want to say that often we do not hear about this, but since this audience is people focus on policy, I think it's important to convey that, quantum technologies, and here in particular quantum software, may be also used for not so good objectives. And so I think we should be increasingly paying attention to the ethical issues and risks associated to quantum technologies, and the policies should ensure that these things are taken into account. Then a very important domain is hybrid quantum classical computer. This has been around for a while. There are some variational approaches to design hybrid algorithms, empirical knowledge on their advantage. And now, in particular, the European Commission's program or joint undertaking of EuroHPC to install quantum processors or co-processors in HPC centers. So this is a very important initiative that will push this use of a hybrid quantum classical computation. But I wanted to convey that there's still a lot to understand to beyond these known variational approaches for quantum hybrid quantum computing and other empirical knowledge. And so I think we need more research from a more systematic approach. And I think this hardware push will be very helpful to really force us to figure this out. First, why do we need this hybridization? What are the right motivations? Because this helps us frame what we then need to do. How can we develop in a more systematic way quantum and classical algorithms? If you ever can develop algorithms systematically, I mean, that's very hard. It's a creative process, to be honest. And for which applications, but also how would hybrid algorithms perform? It's not so easy to benchmark, to have theoretical results that are giving us proofs of speed up, etc. And then, of course, and this is what I think is very good by this initiative from the Commission and EuroHPC joint undertaking, is how to then implement this hybridization. I think there will be, maybe Venkatesh will tell us more about that as well. And I want actually to mention that there is a research project in Quantera called precisely Hybrid Quantum Classical Computing that is trying to address these more fundamental, these more theoretical foundations of this type of computing, which I think we really need to then be able to exploit it for practical applications. Then another one is machine learning from quantum data. Of course, machine learning is, in my opinion, a huge revolution. Quantum information technologies is another revolution. And so you put these two revolutions or even buzzwords together and you get a mega buzzword. But I think there's serious work to address there. The potential is really, really interesting. However, having quantum machines learn from classical data may be challenging. It's still an open question, but just the time it could take to write classical data in a quantum, let's call it memory, quantum register, may be very inefficient. But already for a few years now, people have been thinking, well, but if we use quantum data, then the quantum machine learning could then be very interesting, very efficient, really bring us some advantages. And what is quantum data? Well, quantum data are just states of quantum systems. And so there's this recent idea that I think deserves much more attention and effort, is how to get data from quantum simulations, so the outputs of quantum computations, or even from quantum sensors. That's a much newer direction, let's say, that I think should be explored, and this could bring us a quantum advantage in the quantum machine learning front, potentially in a shorter term. I think quantum advantage on classical data is very, very challenging, but on quantum data is maybe more realistic in a not too far distant period. Talking about machine learning and classical HPC centers and data centers, I think it's no news to you that these technologies are extremely, energy inefficient and energy costly. So they consume a lot of energy. They need to be cooled, which in addition consumes even more energy. So from the sustainability point of view, from the environmental point of view, artificial intelligence and its development is a bit in contradiction with all the, or even mining cryptocurrency, all these classical technologies are a bit in contradiction with the efforts like the Green Deal, etc. And of course, it's for the stakeholders to try and find solutions for that. And I wanted to mention one interesting idea, which is the potential that quantum computers offer also an energetic advantage besides the time to solution advantage. I think this is not a new idea. For example, in my group, we've been working on this since I think 2012. It's a very hard one, but I think it's an idea. The energetic cost and the potential energetic advantage of quantum technology is an idea that recently picked up much more traction and much more visibility. I think this is very good, and I think it should get even more. So, for example, we have here a theoretical result in some ideal conditions where we believe a quantum processor based on trapped ions offers an energetic advantage. So the blue dots would be the energetic performance versus the number of qubits, and then the red and orange dots would be the classical performance of a task. But so these are very ideal scenarios, but it's a first step into going into concrete computations, etc. So it could be that even this is the biggest advantage of quantum computation. As I said, speedups are hard, but this is not the reason not to search for them. On the contrary, this means we need more effort on quantum software, quantum algorithms, to figure out why they are so hard. That's an extremely hard question, by the way, but also to find more of them. But this promising idea of a potential energetic quantum advantage, this is still very much in research stage, and the scaling of this potential energetic advantage, the heavy cost of all the classical control, the classical computation needed to operate a quantum computer, these are obstacles, and so this is still a research direction. So I wanted also to talk about this network called European Quantum Software Institute that brings together institutes in Paris, Portugal, Copenhagen, Amsterdam, Munich, and Riga in Latvia, that tries to push the agenda and research on these topics that I showed here. Of course, there are more people around Europe and the world pursuing them, but we try to then have this more comprehensive approach and joint efforts from experts, more from the theoretical computer science and theoretical physics, always thinking about how to engage and interact with the experimentalists developing the hardware for co-design, with stakeholders who have the use cases for co-creation, and of course also to the stakeholders who have the infrastructure, in particular for the hybrid, but also the quantum computer. So this is a network that we try to have some effort in all these newer directions, and anyone interested in discussing more is very welcome. So these were my points about some new interesting directions in quantum technologies. There are in quantum computation, there are more in quantum computation. There would be more also in communications and sensing that could be left for another opportunity. I do want to still mention today the World Quantum Day, and you'll understand why. This is a bottom-up initiative with colleagues all around the world, in particular many colleagues from the Global South as well, which is very encouraging. And this is a bottom-up initiative. Anyone can set up their events, and we launched this in 2022, and we've had events in all continents, and we're very happy with this. So this is essentially an outreach initiative, but it outreach in any broad sense, and it can also be an occasion to engage with policymakers, or for policymakers to take their own initiatives and promote quantum science and technology. And let me give you an example that even President Biden in the USA tweeted, Happy World Quantum Day, showing an American quantum computer. So there's also a political message to the country and to the other countries about the engagement on quantum technology. So there's also that dimension that could be interesting for you as people more involved in policy making to know. But the main reason I'm mentioning this is that just less than 2 weeks ago, the General Assembly of the United Nations declared 2025 as the International Year of Quantum Science and Technology. So I think this is going to be a very exciting year, an opportunity for disseminate and organize many activities at different dimensions, including at policy level, for quantum technologies. And in particular, the Executive Committee of this International Year has contacted the World Quantum Day to collaborate very intensively and benefit from all the network and infrastructure that we have to promote these events and to catalyze these events. And so we are now going to have World Quantum Days, as they suggested, or try to make every day in 2025 a quantum day. And so this is a bottom-up initiative. I encourage you to get involved and disseminate. And I think this is it. The final comment or piece of information is that here at the Portuguese Quantum Institute, we are organizing the EQTC. This is the flagship, the Quantum Flagship's now annual conference. This is organized in close collaboration with the project QCAS, which you've heard about, and of course with the very important inputs from the Commission. And so I encourage you to attend. The registration is open. If you want to submit posters or people would like to submit abstracts, I think the deadline is the 1st of July. The early bird registration is also now in July. This caters for all the stakeholders in the flagship, and these include policymakers, these include researchers both in academia and industry, but includes also people in the industry that are more on the business development, investment, etc. aspects. So it tries to cater to all these audiences and showcase what is happening in Europe in quantum technology. So I encourage you to attend, and I look forward to welcoming you in Lisbon in November. So finally, just thanks to my group and all the agencies funding our research, and I leave this slide about the conference. Thank you very much.
Thank you, Yasser, for this very interesting talk. You touched many topics, so maybe hopefully we will be able to develop them a little bit more after with a question and answer session. So for the moment, I will invite everyone, all the attendees, to share the questions in the chat or in the question and answer box, and we will answer them at the end after our second talk. So now it's time for our second speaker. Maybe I will share my screen for one last time. I welcome Dr. Venkatesh Kannan, who serves as the Associate Director at the Irish Centre for High-End Computing, Ireland's National Centre for High Performance Computing, APC, and Data Management at ICHEC. He is instrumental in defining and implementing the Centre's vision and strategy for technological solutions related to high-performing computing and federated data services. His leadership encompasses the design and development of advanced high-performing computing and data platforms, working collaboratively with national and international partners across academia, industry, and the public sector. He represents the ICHEC in various national, European, and international programs, consulting with agencies to shape and implement strategic initiatives. So, Venkatesh, thank you for joining us, and the floor is yours.
Thank you very much, Diana. I hope you can hear me, and thanks everyone for joining. I'll start by sharing my screen. So I'll springboard off a very good introduction that Yasser gave us on quantum computation, where it is at and where it might be progressing going forward. To complement that, I wanted to focus a bit more on three items. One is positioning quantum computation as an emergent technology, which is still under rapid development and experimentation, alongside the existing classical computational technology and the efforts that are going on, at least from Europe's point of view, in seeing how they interface with each other. Quantum computation has been engineered and prototyped in almost a silo for a good few years in the beginning, but it's important that we also investigate at a community and a technology level its interfacing on and positioning with the classical computational technology. So that's where most of the focus is. And I'll touch towards the end on the emerging challenges, really interesting challenges in terms of skills development, because these are two different globes or worlds colliding, and the synergy between them is creating a new breed of, so to speak, skilled workforce in research, in academia, and in enterprise ecosystems as well. So I'll touch on all three there. So I myself, I work in ICHEC, like any other member state. We are the National HPC Center for Ireland. And in my capacity, I also lead work packages in a few EuroHPC projects in the context of today's meeting. They are primarily the HPCQS, which is already running, and the EuroHPC integration, which is starting later this year. So the origin for all of this was the community coming together to put together a paper on EuroQCS. That was in 2019 in the middle of COVID. So almost all HPC centers across Europe, research and innovation centers, and also some enterprises participated in writing a EuroQCS white paper. It's still available, but beyond that initial community initiative, what has happened earlier this year in February is, as a part of the Quantum Flagship's strategic agenda, we exclusively added a section. It's 1.2D, and this is available in the QCATS website, the Quantum Flagship website. This section in the strategic agenda touches on the hybridization, or basically the interface of quantum computing and simulation technologies with the classical HPC. So it touches on a few things. It touches on the current landscape. It touches on what is the technological requirements, and it touches on what are the challenges and the roadmap going forward. But long story short, it summarizes this table in the right side. It touches on what does it take to deploy quantum computation technology devices that are experimental now for wider access to the user ecosystem, because the classical HPC world has a huge track record, decades of track record in putting in place infrastructure, putting in place access mechanisms, tutorials, hand-holding the user community in having access to these technologies and supporting the application development and prototyping, irrespective of the maturity of the HPC technology. When GPUs were early stage development 12, 15 years ago, HPC centers still put them in experimental platforms and provided access, and that bootstrapped basically the development of the rest of the technology stack, the software, the applications, the skills, etc. So it's important that we leverage the HPC's capabilities in providing early access, in supporting the co-development of the technology, and also building the skills there. So that's the reason for looking at quantum computation as an emergent technology, an experimental emergent technology, and taking the lessons learned and the resources that are available from within the HPC community to kind of mature that with the user community ecosystem. So deployment and operation is not for production use. We still look at quantum computing devices as lower TRL, so to speak. The individual components are in early stages of development, but the operation of them for a wider user access, for development of the technology on top, is much higher, higher TRL. So deployment and operation of quantum systems in the world of HPC centers is one. On top of that, it's mechanisms through which we can provide access, both through protocols, but also software technologies. And then the tools that are used for software development, application development, benchmarking, programming, compilation, etc. And finally, the more important use cases. Does it make sense, on one hand, to use quantum computation for certain problems? Which problems? When does it make sense to use a combination of classical high-performance computing and quantum computing together for a hybrid problem? So important is that the use cases dictate how the rest of the integration of the HPC and quantum computing platforms work together. So it's a co-design exercise where the use cases inform of the requirements, and the technology then allows the use cases to mature. That's important. And then the pillars on the sides are, these are hugely interdisciplinary skills to develop every element of the stack. We need to build a more pan-European high-level technology support team for user engagement. And by user, I mean not just application developers, it's software technology developers, it's system administration developers, all of them together. So that cross-pollination is important through these support teams. So this strategy is the one that is driving the activities in Europe going forward. So the first pilot was the EuroHPC HPC-QS project. It stands for deploying a quantum simulator, which is still a quantum hardware device that works in analog mode, if you're aware. So it's one type of quantum computation which allows you to simulate naturally quantum systems. So this project started in 2021. It is planned to finish next year. But what it primarily does is it deploys 2 quantum devices, one in ULisbon in Germany and one in CEA, and it brings together a consortium of 6 different members, participating states, and 13 different consortium members to integrate and co-develop them. So even though the deployment is in these 2 member states, there is a consortium that is developing all of the stack on top of it together. That's the consortium here. And this is co-funded. So the European Union basically funds 50% of this, and then the participating states co-funds the remaining 50%. Ireland is a partner indeed, and ICHEC, funded by DFERIS, is the active partner here. And as I said, it deploys 2 Pascal quantum simulator devices. In fact, the first device was delivered to CEA earlier this week, and subsequently, the second device is due to be delivered in Germany in the coming weeks. We look at, as I mentioned, the full stack integration from data center deployment through to system software infrastructure, through to applications and skills development, all of it together. Where this is heading towards is, this was the pilot project, as I said, but subsequent to that, the HPCQS has 6 participating states and 16 consortium members. Subsequent to that, last year, we successfully have 6 more consortia that are procuring quantum computational devices and deploying them across 6 different member states. Now, each of these is not individual member states. Again, it's similar to the HPCQS. Each of these projects is a consortium. So we have from Czechia, France, Germany, Italy, Poland, and Spain. They are the lead partners of these 6 projects. And then each of these has subsequent other member states, other participating states partners. So you might see that it's already grown by more than double, almost triple in terms of participating states covering the European member states, and then the consortium have also grown. So particularly of interest to me, Ireland through ICHEC is participant in the EuroQCS France, but we also co-lead the high-level support team across all of the 6 projects coming forward. So Ireland is going to cross-cut all 7 projects as well. So this is where the European landscape is. There is going to be a constellation of 8 sites that host quantum computation devices within HPC centers, and they're going to be integrated. But then the challenge there is, this is a community development. We don't want them to be developed in silos. Neither does the European Commission or EuroHPC. So there is a strong synergy in all of these projects, sharing software resources, but also knowledge resources in synergizing the efforts of what is being developed. So there's a cross pollination of the technology developed between the different projects being shared and reused going forward. And there's going to be a unified access mechanism across Europe that allows research and innovation users from across academia, industry, and some public sector to have access to all of these systems eventually. So maybe by the middle of this decade, few of these are going to be operational, and by the end of this decade, it's going to be a more mature ecosystem of a federated system of hybrid HPC quantum resources. Now, I mentioned synergization quite a bit, but without going into too many technical details, the reason for synergization is at the bottom layer, there are different modalities or different ways of engineering quantum computing devices. You might have heard of superconducting, photonics, neutral atom in the news articles, but they're all different ways in which you can engineer quantum computing devices. And there are different sources through which these devices are being produced. The quantum flagship activity is being engineering and prototyping these devices. So you can almost imagine that the quantum flagship projects are developing these technologies. The EuroHPC is procuring and deploying these technologies. And there are commercial entities set up as well. So there is public funded development of these quantum devices. There is commercial development of these quantum devices. So it's a zoo basically at the bottom. And what happens is a lower part of the system software has to be specific, at least for now, to these different types of devices. So there is no unified way in which you can have a common software to control all of these devices together. But what happens typically in the classical world is that's still the case for things like an Intel CPU, an AMD CPU, an NVIDIA GPU, or an FPGA, etc. You still have lower level system software that is specific to whoever is engineering it in whichever way. But then as you go further up, the higher level system software, the application programming library tools, and the use cases and applications work on pretty much any underlying technology. And that is where we are able to leverage the classical computation, HPC particularly, compilers, programming models, the schedulers to allocate resources and manage resources, and benchmarking methodologies and tools. We can leverage and extend these that exist in the classical HPC world to consider quantum computation as yet another computation technology, like how it was expanded for FPGAs and GPUs previously. Now, it's not easy, but that's where the community realized that rather than creating a separate siloed stack for quantum computer device access programming use cases, it should be integrated more naturally into the classical HPC world. And as a result of that, the programming tools and libraries across different domains, disciplines, cross-disciplinary, can leverage these abstract, so to speak, or generic higher level system software. And that would enable, considering the current classical HPC applications, that can leverage quantum computing. So one of the primary reasons for looking at quantum computing from the classical HPC world is there are some difficult problems to solve. They're called intractable problems. So which types of problems are more suitable for quantum computation? And like Yasser mentioned, where is the advantage potentially going to come from for which problems? So we would look to the existing difficult problems and be able to look at them in a more natural way rather than in a siloed way. So this is where we are headed in synergizing. And maybe to close out, what we mean is I touched on the skills development, right? So the workforce that can bring all of these technologies together spans multiple layers. So we talk about people that operate the system in data centers or in labs. We have systems administrators, software developers of different types, and then algorithm developers, application developers, and users. That's in the classical HPC world. And a similar strata exists in the quantum world, but these two worlds speak entirely different languages, especially in the bottom part, because the quantum computation programming is now predominantly physics and math driven and domain discipline specific. So these two worlds speak entirely different languages. They work with pretty much mostly different tools, maybe except for Python, like languages. So it's important that we bridge these worlds together. So there are multiple efforts to do that. The EuroHPC is one example, but then at a global level, the IEEE Quantum HPC working group is something that we have set up across the world. So between LRZ, the Munich area, pretty much the US and ICHEC in Ireland, we bootstrapped this. We are coordinating this, but we already have global members participating in looking at how can we develop these technologies and interface them and build a community and skilled workforce towards all of this. There's also an association of supercomputing centers across the world. Almost all HPC centers are part of that. So we are looking at that in that dimension as well. And just to give you a flavor, if you take just the development of hybrid quantum computing and HPC applications, the kind of skills that we are trying to bridge, the language that we are trying to build so that people can understand each other from different worlds, spans the quantum world, quantum information, algorithm programming. The people that have these skills are entirely different from people that have robust software, the classical software engineering, domain engineering, system technology skills, data management skills, teaching and pedagogy. That's most important because we don't have the trainers that can teach all of these in a way, meaning on second page, we dive into math and physics pretty much in most quantum computing courses. And that's easy for some people, that's difficult for some people. So the training material, the people that can train the workforce in future, they are being developed as we see the technology being developed. So this is pretty much where we are headed in terms of synergizing the two worlds. So I'll probably stop with that and give more time to any discussions.
Thank you very much, Venkatesh. Now, yes, it's really time for our question and answer. Yes, sir, thank you for switching on your video again. We can start with Michele Capobianco has quite a few questions. The first would be, how would you update the strategic research agenda considering the new tech evolution of the last few years? I don't know whom of you want to answer that.
I can maybe start with that. The SRIA itself that section was co-written by, I believe, 30 odd people with inputs from the wider community. So it's people that are developing these technologies that are feeding into the SRA. So in a way, the SRA is informed by the development of what is happening through European and regional and national projects. So that is one way in which that SRIA is kept more relevant and updated based on the trajectory of the technology as well.
I would just add that, this is a bottom-up exercise where the community, the different stakeholders get an opportunity to contribute to the document. So the latest version was just published a few months ago in February, and soon another updating exercise, which are done regularly, will take place, coordinated by QCATS. And so the community, any stakeholder has the opportunity to contribute to that with their ideas and vision.
Many thanks. To comment a few questions we have been receiving in the chat, for those who might need certificate of attendance, you can write to either me or Oksana. Our email will be shared in the chat shortly, and you can write us and we will provide some certificate for you. Following on other questions we received from the registration, Jeff Bayala from US asked, what negative externalities are policymakers concerned with in the development of quantum technologies? Can you, both of you, argument a little bit on that?
Maybe I can make a first pass. It's not really negative, but it might be called a conservative approach. Sovereignty of technology and by region or states is one aspect that is important from a political but also a national level. So sovereignty in a regional or a national level is being driving a big part of the quantum technology development. I mean, by that, science, engineering, skills, technologies, use cases, etc. In a way, that is important to consider. But also, quantum computing is such a niche area that only very few people at any level of the stack exist in the world work on that. So it's important that we balance that. And that has been communicated to the policymakers as well, meaning while we go after sovereignty and IP and a leadership role, we shouldn't preclude participation in a global or a wider engagement for co-developing this technology and sharing resources. So that's a balance that is often in the discussion between policymakers and the scientists and people that are doing the heavy lifting.
We're receiving kind of few questions, but we've had quite a few questions, but one that might be interesting was asked by Maurizio D'Abicco, is saying that not all revolutions do actually end up in a proper phase transition. So I think it means that they're not really developed in the end. So what are the evidences in the case of quantum technologies?
Thanks. Maybe I can start here. So, I mean, to me, quantum information and quantum information technologies is a revolution. In the following sense, we live in what we call the information society, surrounded by information technologies, and our, quality of life, health, etc., all are completely dependent on this. Quantum physics, quantum science offers us a new type of information, and so we now have these promising technologies or information technologies that exploit this new type of information, quantum information. These are, of course, quantum computation, quantum communications and networks, and quantum sensing and metrology. It's hard to, predict exactly how this will transform our society and in which sense it's a revolution. Because maybe indeed, I mean, we don't expect quantum computers to completely replace classical computers, certainly not at the individual level. We're talking about complementing, or maybe competing, but probably complementing high-performance computers. Quantum internet will not replace, but will complement the quantum internet, etc. So in that sense, it may not be a revolution. But I think from the capacities that we expect to attain, and we still need to fulfill them in terms of precision, in terms of speed of computation, or even energetic efficiency, and that may be actually a potential revolution, or privacy in communications. This is really a paradigm shift, and so and you can see this by also the time it's taking to engage stakeholders in from different backgrounds around the world, but they are all engaging, right? So it's really cross-cutting. And so I do believe this is a revolution. And, these scientific revolutions don't necessarily have a phase transition impact in our society. Think of classical computation. That's certainly a revolution, but see how it went from a computer being in a big room, and now it's in the wrist in our smartwatch. So in that sense, I think it's a big revolution without the need of this phase transition visible in society.
Many thanks. So just on a more general level, we've had on this maybe this same topic from, I'm sorry if I'm mispronouncing it, Anikan Afangide. He has more on a focusing on African policy. How can, but maybe this question can be widened to other countries as well. How can African policy collaborate with foreign studies and research on opportunities? I mean, what are the opportunities for countries that maybe are not from Europe and have a little bit of difficulties catching up?
Yeah, I can start by addressing this one. I would have a lot to say. Actually, I'll try to be very brief. I would say first there is a contradiction, which is the following. On the one hand, quantum technologies are sovereignty technologies. And so by definition, states or unions want to be protective of them. That's only natural. On the other hand, there's what people call in general around the world a digital divide between different regions of the world. And now I would add there's also a quantum digital divide. And this, I think it's can be very negative at different levels. So first, in terms of research, development, and innovation, I think no region of the world is completely self-sustainable, and we only benefit from these collaborations. But also in terms of making the world a more equitable place, It's dangerous if, you know, these emerging technologies and these powerful technologies are only in the hands of a few. It's also maybe a danger if they are in the hands. It depends on the few, of course, and then this becomes a strategic and political aspect. As a scientist, I think we should, of course, have a responsible attitude and understand the risks and be cautious. But at the same time, we should also promote that, you know, knowledge is shared as much as possible, and the use of the technology and even the technologies themselves are shared as much as possible. So this, I think, is a contradiction that is not easy to solve, but I think it's something that we should address. And so with colleagues from the Netherlands, we organized actually in Lisbon last November at the Academy of Sciences a session we called Global Quantum Connections, and we brought different stakeholders, including for OECD, UNESCO, etc. I mentioned these stakeholders that are maybe more close to the audience of policymakers, to try and start this discussion. I mean, we don't have solutions, but I think this is a discussion that should be addressed. And there is the plan now to continue this discussion under the umbrella of the UNESCO to make sure this is a multi-stakeholder and the Global South can partake. I think at least we should raise awareness and make sure you know, less developed countries are not caught by surprise by these technologies, as it's happening now with AI, and so I think this could be anticipated. And a final point, I don't want to go too long, is that this one of the visions for this International Year of Quantum Science and Technology as a initiative of the United Nations is to see how quantum science and technology can not only contribute to these sustainable development goals, but also create a vision where, you know, the different regions of the world can partake in this quantum revolution. But so this is work to be done. Thank you.
I want to just quickly chip in with some practical things as well. So the Horizon framework has had a traditional, specific to Anikan's question, has had an African initiative covering certain key disciplinary areas. Again, there is Africa Initiative 2 that is ongoing into the Horizon Europe part. The Marie Curie action, for example, supports research and innovation related training, for example, but they are currently limited in the disciplines in food security, for example, health, environmental and climate related areas, topics. So one potential direction is to expand that potential existing framework to also cover disciplines related to quantum science, technology, skills development, and collaborative research. That could be one direction to leverage existing instruments.
And maybe I just want to add something very quick, which is, you know, some use cases that could come from different regions of the world that we would not think otherwise here in Europe and other places. Like, for example, how you know, advanced computing can be important for planning and implementing basic sanitation, etc. So this is fortunately a challenge we don't have here in Europe, but you know, these challenges could come up from. So there's also contributions that could be important.
Many thanks. On the side of more like there are several questions about policymakers, right? So what do you think, in your opinion, what is the current level of awareness about quantum technologies among policymakers, and also about their, I mean, these more social, let's say, aspects to it? So there something you reckon they're missing in the knowledge, in the activities that have been developed by the policymakers at the moment, where there might be some adjustment, let's say?
I don't know, Venkatesh, you want to say? Okay, I can say something quickly. I mean, so I would return this question to the policymakers in the audience, although I guess if they are here, it's because they do have some awareness. I mean, what I can say, maybe two things. So first, given the number of countries and regions of the world that started their national quantum initiatives, quantum agendas, quantum programs in all continents, I think this means that, you know, policymakers are aware. And I think this is very interesting because it shows there's a a link, a collaboration between the research stakeholders and innovation stakeholders who are pushing this field from the bottom up, and the policymakers who there's a dialogue that transforms these bottom up activities into a top down vision. I think Europe and the European Union in particular is a great example of that. Thanks to the efforts of the European Commission and the community representatives and coordination of the flagship to really create a link and hopefully now increasingly collaborative link in the context of the Quantum Declaration or Quantum Pact. So I think this is a pretty impressive development, but I think we need more. And so more engagement and involvement of policymakers is welcome. And congratulations also to Oksana, Diana, and Constanze and the colleagues at QCAS for setting up these I think, so far very successful sessions online.
Yes, and maybe from personal Irish experience, I can speak a bit more from that. It depends on the rest of the strategic science and innovation agenda of the country itself, of the nation. It has to be grounded to that. So on one hand, that is the scientific research and innovation and enterprise ecosystem in any state, and then there is strategic priority areas at a national level. I think it's important for the policymakers and the community to first synchronize on that, because a very simple example is in quantum computation, a country and its ecosystem can work in any level of contributing to the technology development or all of it. It pretty much depends on what is available in terms of capabilities now to leverage in the ecosystem, in the scientific ecosystem, in the enterprise ecosystem, in the funding instruments that are available to the member states within their national budget, but also these co-funded efforts with the European Union. So I think that would dictate, so to speak, the prioritization. So if we talk just about quantum technologies, then every state doesn't necessarily have to do every bit of the stack, but it's important for that state and its user and scientific community to come together and prioritize where do we want to participate and magnify our efforts and develop a wider ecosystem.
Many thanks. Since we have last 5 minutes left, I would like for you to help me address some a few questions about participations, because we have some people asking for PhD programs, other people asking for how being a company like an SME, how can we reach the flagship? How can we reach the opportunities that there are? So how would you suggest for these people to behave, Yasser and Venkatesh?
So regarding PhD positions, I think everywhere in Europe, there's many interesting projects ongoing that are recruiting PhD students. So in particular, the Flagship project. So I would encourage you to go to the website of the Flagship, qt.eu, QT for Quantum Technologies. And there, I think there's a section devoted to job opportunities, but there's also, I think, lists to the websites of the many projects that are happening in Europe, and often they are recruiting at some moment in time. So I think there are opportunities. There are also now the development of PhD programs devoted to quantum information science and quantum technologies. So I would say in Europe, there's many opportunities, and the starting point would be the qt.eu website and all the project sites and initiative sites that are linked there. If not, and if I can be of help, feel free to contact me. But I think there are a lot of information online.
I agree. Just reach out to the projects, just reach out to the organizations that you see working in it. Like Yasser said, QT.edu tries to pull all of that together, but sometimes there might be different delays, etc. So positions might open. So just reach out to people. There is a lot of opportunities coming.
Yeah, I might add, maybe for companies, there is the Quick consortia that also might be creating some connections. So there is also a website about that.
Sorry, if I may, Diana. So if it was about wider networking opportunities to collaboratively work, etc., just watch out for the quantum excellence centers that are going to be set up early next year. So there was a call from EuroHPC to set up at least 2 quantum computing excellence centers, bringing the community from research and innovation across academia industry together. So when these centers are set up, they might actually be the hub for you to reach out for different kinds of engagement, whether you want to co-develop a solution, whether you want to find opportunities to leverage technology, contribute, etc. So maybe watch out for the centers of excellence from next year.
Yeah, many thanks. I mean, we didn't have time to cover all the questions and all the possible development that we might had, but I'm sure, I mean, we can contact us, the organizers, and we can put you in contact with the speakers and so on. And I'm sure we will be very happy to help you with all the questions that you might have. So I thank everyone for joining us today. I will remind you again of the next session that we will have in September. So don't miss it. We will share it with the user channels on Instagram, on LinkedIn, sorry, and on the newsletter, the flagship, the Quantum Flagship newsletter. Also, you will see that at the end of this webinar, you will be asked a little poll because it will help us organizing next year sessions if we see that you are interested in it. So please answer to this poll. So thanks again, Yasser and Venkatesh, for being with us today, and see you hopefully in September. Thank you, everyone.
Thank you very much, Diana. Thanks, everybody. It was very interesting.
Thank you very much, everyone.